All right, if you're gearing up for your IGCSE chemistry exams, you are in exactly the right place. Today, we're going to build the ultimate study guide for mastering chemical reaction types so you can walk in and ace those questions with total confidence. Let's dive right in.
You know that feeling, right? You're staring at a chemical equation and your mind just goes blank. Well, trust me, you are not alone. So many students lose really easy marks just by misidentifying these reactions. We're going to put a stop to that right now.
This is it. This is where we stop throwing away those points. We're going to break down the secrets to spotting every single reaction type every single time so you can walk into that exam feeling ready to grab every last mark. So here's our game plan. First, we'll crack the overall code. Then, we are diving into the two biggest troublemakers, acid-base versus neutralization, and addition versus condensation. After that, we'll cover the easy wins and wrap it all up with the ultimate cheat sheet.
Okay, first things first, this is not about brute force memorization of a long list of names. No way. This is about learning to see the patterns. It's like being a detective, looking for the simple clues hidden right there on every equation that tell you exactly what's going on. And trust me, once you see them, you can't unsee them.
All right, let's tackle what is, without a doubt, the #1 mistake students make. So many people use the terms acid-base and neutralization as if they're the same thing, but they are absolutely not, and you can bet your examiner knows the difference. Let's break it down. Think of it this way. Acid-base is the big umbrella category. It's super broad. An acid reacting with any base, like ammonia or sodium carbonate, is an acid-base reaction. But neutralization, that's the VIP section. It's a much more specific type where an acid reacts only with an alkali. And it follows two strict rules. It always forms water, and it's always exothermic, meaning it gives off heat. So remember this, all neutralization reactions are acid-base reactions, but not all acid-base reactions are neutralizations. So what is this special ingredient, this alkali? Well, it's just a base that does two specific things. One, it dissolves in water. And two, this is the critical part, it can donate hydroxide ions, those OH- ions. If there's no alkali involved, it simply cannot be a neutralization reaction. It's that black and white.
Next up, another classic that trips people up, especially in organic chemistry. Addition versus condensation. But you know what? The secret here is actually super simple. It all just comes down to counting the products.
Let's start with addition. The rule here is ironclad. You can have two reactants or even thousands of monomers joining together. It doesn't matter. If they combine to form only one, I'll say it again, one single product at the end, it is an addition reaction. That's the whole story. Now contrast that with a condensation reaction. Here, your reactants still join up, but they also kick out or release a small molecule. Usually it's water. A perfect example is making an ester. An alcohol and a carboxylic acid combine, but a water molecule always gets released in the process. That little molecule getting kicked out, that is your telltale sign that you're looking at condensation.
Okay, we've wrestled with the tricky ones. Now for the fun part, the easy wins. I like to call these the cheat codes of reaction types. These are the ones with such obvious dead giveaways that you can spot them from a mile away.
Listen up, because this is your golden rule. Seriously, if you look at an equation and you see a pure element, like Mg all by itself, or O2, involved as a reactant or a product, it is always a redox reaction. No exceptions. Why? Because for a pure element to react, its oxidation state has to change, and that change is literally the definition of redox. This is an instant mark on your exam. And here are 3 more easy ones. You see something burning with oxygen? That's combustion. You mix 2 clear solutions, and suddenly a solid appears out of nowhere? That's precipitation. And if you see that little triangle symbol over the reaction arrow, that means heat is being used to break a compound down, which is thermal decomposition. Simple, right? Okay, we've covered the tough ones and we've covered the easy ones. Now let's put it all together. It's time for your final cheat sheet. Everything you need for revision, all in one place. And here it is. This table boils everything down to one single identifier. You see something breaking down with heat? Boom, thermal decomposition. You spot a pure element? It's redox. Only one product formed? That's addition. A small molecule gets released? Condensation. Seriously, this table is your new best friend for studying. So there you have it. The code is officially cracked. You have the patterns, you know the rules, and you have the cheat sheet to identify any reaction the examiner throws at you. The only question left is, which one will be the first easy mark you score on your exam? Good luck and happy revising.